Welcome to the Explainer. Today, we are jumping right into one of the absolute workhorses of Kubernetes, deployments. We're going to see how a simple text file, just a blueprint, can bring an application to life that, get this, heals itself when it breaks and updates without ever going down. Pretty cool, right?
So let's start with a question every single one of us has faced. How do you keep your app running perfectly, 24/7, even when things inevitably go wrong? The answer, and this is a core Kubernetes philosophy, is something called desired state. Instead of micromanaging and telling Kubernetes how to do every little thing, you just tell it what you want. You describe the end result, and Kubernetes figures out the rest. It's a total game changer.
Okay, so here's our game plan for today. We'll start with the deployment blueprint. Then we'll actually create and verify it. After that, the fun stuff. We'll see auto-healing and auto-scaling in action. We'll cover the magic of zero downtime updates, and we'll finish up with some golden rules for production. Let's do it.
First up, the deployment blueprint. We've got to understand the YAML file.
Now, before we even look at the code, here's the most important piece of advice I can give you. You don't memorize YAML. You just don't. The real key is to understand the structure, the logic behind it. What are you actually trying to tell Kubernetes to do? That's what really matters.
Okay, let's break down this YAML file. Up top, you've got apiVersion and kind. That's just telling Kubernetes what we're making. In this case, a deployment. Then you give it a name. But the real heart of it is the spec. This is where you describe your desired state. See replicas? We're telling it, hey, I want exactly 3 copies of my app running. The selector is how the deployment finds and manages its pods. And then the template? That's the blueprint for the pods themselves, all the way down to the container section, which says, okay, for each of these pods, run this specific nginx container. It's all just a declaration of what we want.
Now, here is a super important detail, especially if you're prepping for an interview. A deployment never, ever creates pods directly. What it actually does is create a replica set, and then the replica set is the one that creates the pods. Think of it like this. The deployment is the big boss, the manager, who says we need 3 workers. The replica set is the supervisor who actually goes out, hires the 3 workers, the pods, and makes sure there are always 3 on the job. It's a hierarchy.
All right, section 2, creating and verifying. Let's bring this blueprint to life.
Okay, we've got our YAML file. How do we make it real? It's literally one command, kubectl apply-f deployment.yaml. That's it. We're just handing our blueprint to Kubernetes and saying, go make this happen. And Kubernetes takes it from there.
So after you run apply, what's next? You always verify. We're going to check each layer of that hierarchy we just talked about. First, the deployment itself, then the replica set it created, and finally, the actual running pods. And here's what that looks like. Kubectl get deploy shows us the big picture. nginx-deployment is up, and 3 out of 3 are ready. Good. Then kubectl get rs. That shows us the supervisor, the replica set, and yep, its desired count is 3. Perfect. Finally, kubectl get pods, and there they are, our 3 individual worker pods, all happily in the running state. Everything looks exactly as we planned.
Okay, now for the really cool part. Let's see some auto-healing in action. We're going to see what Kubernetes does when things go wrong, because in the real world, things always go wrong.
To prove the point, I'm going to deliberately break something. I'm going to delete one of our running pods with kube control delete pod. Imagine this is a server crashing, a network glitch, whatever. The pod is gone. And watch this. The instant that old pod starts terminating, a new one is already pending. It's being created, and boom, it's running. The replica set saw that there were only 2 pods, but the desired state was 3, so it immediately fixed the problem. No one had to wake up at 3 a.m. The system just healed itself. That's incredible.
So, let's be super clear about what just happened. I didn't create that new pod. I deleted the old one. It was the replica set that detected the mismatch between what is and what should be and automatically recreated it. That's the reconciliation loop in action, and it's the foundation of Kubernetes resilience.
Okay, so our app is resilient. That's amazing. But what happens when we get a sudden spike in traffic? We need to scale up. Let's see how we can do that on demand. You know what's great? We don't have to go mess with the running pods at all. We just go back to our blueprint, that YAML file, and we change one single number. We're just going to change replicas from 3 to 5. We're just declaring a new desired state. And then, what do? We run the exact same command as before. Kubernetes smart enough to look at the new file, look at what's currently running, and just figure out the difference. It knows it just needs to add 2 more pods.
And just like that, you can see we now have 5 pods running. The ReplicaSet got the new order, saw it was short by 2, and created them automatically. Scaling is that simple. You just change the blueprint.
Okay, next up, the magic of zero downtime. We know how to heal, we know how to scale, but how do we update our actual application code without taking everything down?
This is what's known as a zero downtime deployment. The whole idea is to make sure your service stays available during an update. Kubernetes does this by creating the new pods before it gets rid of the old ones. It's a carefully managed handoff.
And here's the key phrase to remember: parallel creation and deletion. During what's called a rolling update, Kubernetes will first spin up a new pod with your new code. It waits for that pod to be completely ready and healthy. Only then does it terminate one of the old pods. Then it does it again. A new one comes up and old one goes down. It does this one by one, ensuring there are always healthy pods available to serve traffic. No downtime.
All right, let's wrap this up with some production golden rules, a little debugging, and some best practices.
Okay, 2 commands you absolutely need to know. First, if you're trying to figure out why a pod failed to even start, use kube-control describe pod. This will show you Kubernetes events, like if you misspelled the image name or something. But if the pod is running and you want to know what happened inside your application, like your code threw an error, that's when you use kube-control logs. So remember, describe is for Kubernetes problems, logs is for your app problems.
And finally, the golden rule, the one thing you should take away from all of this. In a real production environment, you should never create pods directly. Just don't do it. Always create a deployment and let Kubernetes manage everything. A raw pod has no supervisor. If it dies, it's just gone. A deployment gives you the auto-healing, the auto-scaling, the zero downtime updates, all of it. Let the controller do the work. That's how you build systems that last.